Welcome to our second flipped classroom lecture. We're going to go over the atomic radius trend on the periodic table. Here are the three topics I would like you to know or have a grasp of before you come to class. I would like you to be able to explain how we can determine atomic radius. I would like you to be able to tell me the trend for the atomic size going across periods and down groups. And I would like you to be able to explain what shielding is, be able to illustrate it, and why it's important in atomic size. All of this we will learn today. So how we determine atomic radius. So an atom, it never has a fixed radius. So if you remember some of the models that we've seen, like you've seen this nucleus with energy levels surrounding it, and it really looks like, or maybe you drew this model, the quantum model, where you see this like S orbital around it. This would be S. It looks like they have a clear border. You see how it looks like they have this border around it, but that's not true, okay? These atoms, they fluctuate based on their environment, and really, according to what we know so far about the atom, we really can't be sure where an electron is found at any time. So we can't honestly say how large an atom is at this point with our technology that we have, maybe in the future, but right now we cannot. So how we determine atomic size or atomic radius is we basically have two bonded together. So we have two atoms bonded together. So maybe we have like hydrogen gas, okay? So with hydrogen gas, we would have two atoms. Let's just say that's the cloud, okay, an electron cloud. And then we have these nuclei, okay? So we can actually see where the nucleus is because it's very dense, and that's much easier to find than an electron. Remember, the electron's weird. Sometimes it's a wave. Unless we disrupt it, then it's a particle. So we know the distance between the distance between the two nuclei. And if we split that distance in half, okay, if we split the distance in half, we're able to find our radius, okay? So we would at least, when we talk about atomic size, this is how we're measuring it. We're actually talking about this distance that we have this whole distance, and then we cut it in half. So we're actually talking about a radius of an atom. And with that radius, again, it could fluctuate, it could change, but it's a radius when it is combined with another atom, okay? So that's how we can determine atomic size. So it's not like we have this tiny little ruler where we measure how big an atom is. So there are group trends on the periodic table. So with the group trend, remember guys, a group on a periodic table, I'm sorry, I'm not like the best video lecturer, but when you have a group trend, so let's say, let's just go all the way, let's just start right here. Okay, so when you have a group trend, okay, so remember guys, a group is something vertical. So the group trend is that the atom sizes gets bigger, okay? So as you go down the periodic table, the atoms get bigger, okay? And that's due to the occupied energy levels. So remember, energy levels, you increase the number of energy levels as you go up. I'm going to use the same paper. But remember, this would be one energy level, this would be another energy level, and this would be a third one, okay? So these are called energy levels. So for each energy level, that is you add a circle around the nucleus, or an energy level around the nucleus each time you go down the group. So that's why it's increasing in size. As you, sorry, I forgot I had a double slide there. So the periodic trend for going across a period. So for example, let's take this period, okay? There we go. As you go across this period, okay, the atomic size will decrease. So as you go this way, it actually gets smaller. And you would think, because as you go from left to right, you're adding more electrons. So you would think that that electron cloud would be the same. Or I'm sorry, would get bigger. So we have this nucleus, okay? And let's just, this is just 2 energy levels. So let's do lithium, okay? So we have lithium. Lithium is number 3. So we have 3 protons here. We'll just draw 3 protons. I don't even, and we'll say it's atomic number 7, so there's 4 neutrons in there somewhere. Okay, and then we have 3 electrons. So 1, 2, 3. So we have 3 electrons in lithium. And as we go, we'll do beryllium. Okay, so beryllium, Be. Beryllium is atomic number 4, so for sure there's 4 protons. I'm sorry, I have my dog here, Fistiki, so he's flapping his ears. He's a Lucanico dog. So we have 4, and its atomic number, or mass number is 9, so we have 5 neutrons. It really is not the point here. But anyways, it has 4 electrons. So its atomic number is 4. It has 4 electrons. 1, 2, 3, 4. So it has 4 electrons. So you would think because it has 4 electrons that the atomic size would increase as you go across a period. And this would have 5 electrons, 6 electrons, 7, 8, 9 electrons, and 10. So, I mean, it would make sense that it would get bigger, but actually it doesn't, and that's because of these protons. These protons are positively charged, so this positive charge will actually pull in these electrons towards itself, towards the protons. So the atom is actually shrinking as we go to the left. I'm sorry, as we go to the right. Okay. Moving on, shielding effect. All right, so the shielding effect, this concept is, it's basically saying that as you, let me show you a periodic table. So the shielding effect says that as we go down, okay, as we go down and we get more electrons, the more electrons we have, the more they are shielding that pulling effect that the protons are causing. So again, let's just draw something. We're going to draw just a solid nucleus. We're not going to have protons in there. We're going to draw a solid nucleus, and we have energy levels, okay? So let's just draw one with a couple of energy shells. So energy levels, sorry. So we have 2 electrons on this side on the first energy level. That's the maximum it can have. And then we have 8 on the second one. And for all you guys know, we have 8 on the third one. Okay. Third one can have more. It gets weird once we start talking about electron configuration, but I'm not going to scare you right now. So basically what kind of happens is these electrons, let me see if I can, there we go. So these electrons will, remember electrons have a negative charge, okay? They all do. And so these negative charges, remember that like charges repel each other. So this also has a negative charge, and this one does too. So what will happen is this electron will repel this electron to push it out this way. And same with this one, it'll push it out this way. And then these will also, this one will kind of, it repels these two. So these two are actually going to be pushed out that way. So all of these forces are acting on each other. All of these negative charges are kind of pushing these electrons out. And then remember the middle is positively charged. So the effect of the protons aren't going to be as strong on the outer electrons as they would be if there were less of these charges kind of pushing them out that way. So that's basically the shielding effect. Let me get that back out. That's basically the shielding effect. The inner electrons are basically shielding or blocking that attraction the protons have on the electrons. So they actually get pushed out further, so that's why the atomic radius is actually bigger as you have more electrons. Okay, and this is a slide kind of illustrating what I just said. The electrons are repelling each other, pushing them further away from the positive charge that would actually be pulling them in. So the effect gets kind of amplified as we get more electrons. And then this is a slide where I'm just showing you various atom sizes. It doesn't include the transition metals, it doesn't include inner transition metals, but it kind of shows you that trend that you see on the periodic table, where you see how lithium is right here, where you see how lithium and then sodium is bigger, and then potassium and rubidium, and they just get bigger as you go down, and then as you go to the right, it's getting smaller. So just kind of keep those trends in mind and kind of organize them in your thoughts, because we will learn about 3 or 4 more trends on the periodic table, and that's kind of, in my opinion, one of the most difficult parts of this unit is getting those trends organized and knowing what gets smaller and bigger, which way up and down columns and side to side on periods. So again, check out those bullet points. Make sure you know those bullet points when you come to class, and you will be given a quick 2 to 3 question quiz on them.